Beep boop. Hello everyone. On this episode, I'll be talking about unit conversion and dimensional analysis, presented by me, Blueberry, a dumb VTuber.
What is unit conversion and why is it important?
Unit conversion is a process where a unit of measurement is converted to another unit of measurement that represents the same value. For example, inches and centimeters represent length, seconds and hours represent time, even though they have different units. Why is it important? Unit conversion is extremely important. You may have heard of Mars Climate Orbiter. Rest in peace, Orbiter, you will be missed. Its mission was unsuccessful due to a navigation error caused by a failure to translate English units into metric units. And at the time, this mistake costed over $300 million, and adjusted to inflation for 2023, it costs over $500 million, so making sure you get the right value of measurement and the units matters a lot. For example, let's say you're baking a cake. 25 grams of flour is not equal to 25 cups of flour, and that will make a big difference, since the cakes will not even be the same thing, and one of them may not look like a cake. So, making sure you get the correct units and the correct values are very important.
What are SI units?
First, let's learn about SI units, especially for Americans like me, because we don't actually use this system on the daily. SI units are the International System of Units, also known as the metric system or metric units. So it uses metric prefixes, which are based on multiples or numbers of magnitude of tens. For example, here we have this chart with all the metric prefixes. If we look at the base unit and we look at kilos, we can see that kilos has a factor of 10 to the third power, and this means that a kilogram is 10 times 10 times 10 greater than the base unit. So it is 3 orders of magnitude, or 3 multiples of 10, greater than the base unit. If we look below the base unit, this part of the chart shows magnitudes of a lesser value. So here we have centi, and centi is 2 orders of magnitude less than the base unit, and that can be seen by the factor, which is 10 to the negative 2. SI base units. So what are SI base units? SI base units are the standard units of measurement that can be used to describe anything and everything. So here's a chart of all 7 of them. So here if we look at the measurement, we have time, which the SI base unit for it is seconds, and the symbol is S. Length would be meters, mass, kilograms, and so forth. All units are made up of SI base units, and units can be broken down into their SI base unit form. For example, here we have 1 volt, and this can be broken down into kilograms times meters squared times seconds to the negative third and ampere to the negative first. And all units can be broken down into their SI base unit form. Converting simple values. First, let's go over single unit conversions, or converting simple values. You likely already know how to do this, but if you don't worry. We have 2 examples here. The first one is to convert 5 inches to centimeters using the conversion factor, which is given right here. You likely already know how to solve this, but if you don't worry. You just need to multiply 5 times 2.54, and that is because 1 inch is equal to 2.54 centimeters, and you want to convert 5 inches. So you simply multiply 5, and you get this value. Similarly, for example 2, you want to convert 7 pounds to kilograms with this conversion factor. And since you want 7 pounds, and this conversion factor gives you the equivalent value for 1 pound, you simply multiply it by 7 and you get this value. What is dimensional analysis? Dimensional analysis. Although it may sound fancy, it is just a method of unit conversion. This method of conversion involves multiplication or division by a numerical factor, which is also known as a conversion factor or a conversion ratio.
How to do dimensional analysis.
For dimensional analysis, you simply use conversion factors and ratios and multiply them to get the units that you're looking for. In fact, for the previous problem, you technically already did this, but you just did it in your head. So for the first example, which is the same example as 2 slides ago, since we have the conversion factor where 1 inch is equal to 2.54 centimeters, you can get this ratio over here. We can see that inches are at the bottom here, and it is given as 5 inches, so inches should be at the numerator. Position them so that you can cross them out. So here we have inches here and inches here. You can cross them out, and you simply multiply, and then you get the same answer as we got previously. So here's a little tip. Make sure the units you don't want cancel out. And you can flip the conversion ratio to however you like, as long as it cancels out. And you can check your final answer by making sure all the units are correctly in the numerator and the denominator. For example, if I got the conversion factor of this and I wrote it as 1 inch over 2.54 centimeters, you would not be able to cancel out inches, and instead you would get this value. So what you need to do is simply just take this and flip it, and then you will be able to just get centimeters. For the second example, you do the same thing. Find the conversion factor, turn it into a ratio. We're given 7 pounds, and pounds is at the numerator. So you make sure that pounds is at the denominator for the ratio. If you wrote it as 1 pound over 0.45 kilograms, no problem, simply flip it. That way you can cross out the pounds, multiply it, so you get this value, which is the same as 2 slides ago.
Dimensional analysis for values with multiple units.
When doing dimensional analysis here, it is the same process for a single value, just like the previous slide, but this time you use multiple units and multiple ratios. So for this example or this question, we have the given velocity, which is in kilometers per hour, and we have to rewrite this value in meters per second. I've actually shown it 2 ways here, but I will go over it the first way, which is to convert the different measurement units individually. So here I am changing the length unit, and on the bottom one I'll be changing the measurement of time. So let's first go over changing length. So if you remember from the metric system, we have this chart with different conversion factors, and we know that meters is the base unit, K is for kilo, and for kilo you have 10 to the third power. So that means 1 kilogram is 10 to the third power meters. So those are equal to each other. So we take a ratio or conversion ratio of that, and we can multiply it with this. So as we see that kilometers is on the numerator, or the kilometer unit, so it's written like this. And this ratio I have here is written as 1 kilometer over the 10 to the third meters. So because we want to cross out the kilometers, we have to flip this conversion ratio to have it 10 cubed meters over 1 kilometer. That way you can cross out the kilometer. And once you get that, you have this value. So you get this value, but it is now in meters per hour. So you can take this value, bring it over here, and we want it to be in seconds. So you find that 1 hour is equal to 60 minutes, and we find that hours at the denominator. So you want to cross the hours out. So now you have a minute in the denominator. You know that 1 minute is equal to 60 seconds. So you make a conversion ratio for that. So I have that here as well. You can cross out the minutes, multiply all these values across, and you get this. So what I'm showing down here is the same process. It's just all at one time. So instead of breaking it up into different measurement units from like length and time, I just simply did it all at one time. So you can go with the original value in kilometers per hour. We have the conversion to meters right here. We have the conversion to seconds right here. And you get the same value for both. So this one line is equivalent to these 2 lines.
Converting to SI base units.
So sometimes you will need to convert values into their SI base units in order to complete a calculation. In this case, we will convert 55 miles per hour to the SI base units. So if we look at miles, miles measures length. So we can go to this chart with all the 7 SI base units, find length, so it should be in meters. An hour is a measurement of time, so it should be in seconds. And here we are given the conversion factors. So You can take this conversion factor, make it into a ratio, just like this. Here we can see that miles is in the numerator. We put our given value like this. We write the conversion ratio so that miles is in the denominator. That way we can cross out miles. So now we have it in meters. And then similarly to the previous problem, we can change hours into seconds using these two factors. We cross out the hours, cross out the minutes, and we can see here that meters and seconds are left. So we just multiply across and we get this value for 55 miles per hour is equal to this value in meters per second.
Round 1.
Example 1. In this example, we have to find the area in millimeters squared. So here is our rectangle, and to find the area you just multiply length times width. So we have the area in 6 inches squared, and then we can convert that into centimeters. So we can take this conversion factor, make a conversion ratio, but don't forget to square the conversion ratio because it is inches squared. So you need to square this conversion factor, that way you can cross out the inches squared, and then you get this value in centimeters squared. Then you can convert centimeters squared to millimeters squared. So from this chart here with the prefixes, we know that 1 centimeter is equal to 10 millimeters. With this, you can flip this ratio because centimeters squared is in the numerator. Square this ratio, that way you can get centimeters squared. You can cross out these values, and then you have millimeters squared left. Multiply, and then you get your final answer. Example 2. For this example, we have to convert 120 kilometers to miles. And here is the given conversion factor. So we take this factor, turn it into a conversion ratio. We can see that the given value is kilometers in the numerator. And in order to turn it into miles, we have to cross out the kilometers. So turn this conversion factor with the kilometers at the denominator. That way you can cross them out. Multiply the numbers across, and you get this value, and the only unit that is left is miles. Example 3. Last but not least is this example. Convert 100 horsepower to SI base units. So here we have two conversion factors. Take the first conversion factor, turn it into a conversion ratio, make sure that the horsepower units cancel out, and take the second one, convert that into a ratio, make sure the watts cancel out, and then multiply all the numbers, and then you get this as your final answer. And this is all in SI base units, and we can check. So we have kilograms, meters, and seconds, which are all on this chart. If bears are so... I'm just a VTuber, so please note, I try my best to get everything right, but I could be wrong on some stuff, so please do your own research and review things, plus extra review will help you understand the material. With that, thank you so much for watching. Please consider liking and subscribing, and beep boop.
Bye. Bye.